In this video, we're talking about applications with graphing. There's two types of applications. There's applications with zeros, meaning that we're usually going to use the quadratic formula to solve these. You're essentially figuring them out when the parabola hits the x-axis. That's what we're looking for in some of these types of problems. Other of these problems have to do with finding the minimum or maximum value. Whenever you see minimum, maximum, peak, valley, think vertex. You're going to try and find the vertex. These are two very different problems, and it's going to be up to you to judge which is which. Let's read this problem. A bush plane airdrops some medical supplies. The plane is flying at a height of 235 meters at a speed of 250 kilometers per hour. The path the supplies take follow this equation. Height equals 235 minus 4.9 t squared, where t represents time in seconds. How many seconds until the supplies land? Well, if the supplies have landed, I'm going to draw a horrible picture here. Here's our plane. Whoa. Here's our plane, and they drop the supplies out. So they're dropping the supplies out, and then at some point the supplies have landed. The supplies have landed at a height of 0. So we're going to ignore this 235 meters and a speed of 250 kilometers per hour. We do not need to build an equation in this problem because we're already given the equation. We have the height equals 235 minus 4.9 t squared. So in this case, since we're trying to find where t represents the time in seconds after the supplies land, 0 equals 235 minus 4.9 t squared. We could solve this using the quadratic formula. We would have a value of negative 4.9 and a b value of 0, because there's no t term, and a c value of positive 235. However, when we don't have a b value, there is an easier way to do this, and that way is to isolate the t squared term. Let's do that instead. I am going to subtract 235 from both sides. This gives us negative 235 equals negative 4.9 t squared. From here, I'm going to divide both sides by negative 4.9. Because it was multiplied in, we're dividing it out. And negative 235 divided by negative 4.9 is this ugly number of 47.959, so on, 18, I think we could probably stop there, equals t squared. At this point, what I want to do is undo the square. And so we undo the square by taking the square root of both sides. When we take the square root of that, we have both a positive and a negative version. However, since this problem is talking about time, we're not really thinking about going back in time. It's not like our package is going to jump up into the plane and then fall back out of it. So we can safely ignore this negative version. So I'm going to take the square root of that number there, and I've gotten t equals 6.925, and the numbers keep on going. And this is in seconds. I didn't mention anything about significant figures, but I think it's safe to probably round to just 2 significant figures in this case. So our answer is going to be 6.9 seconds. Next problem. Went the wrong way. Next problem is another application problem. So it says, the number of tickets sold each day for an upcoming performance of Handel's Messiah is given by this equation right here, where x is the number of days since the concert was first announced. When will the daily ticket sales peak, and how many tickets will be sold that day? So what I'm looking at right now is we're asking when that ticket sales will peak. That right there tells me that we're looking for a maximum. So if we're looking for a maximum or minimum, what we want to do is we want to find the vertex. This equation is given to us in standard form. To find the vertex in standard form, the x-coordinate of the vertex is given by negative b over 2a. In this case, our a is negative 0.45, our b value is 9, and I don't really care what our c is. So to find the x-coordinate of the vertex, what we're going to do is we're going to do negative 9 divided by 2 times negative 0.45. This becomes 9 divided by 0.9, because negative divided by a negative is a positive, and we can further simplify that. If we think about it as 90 over 9, it simplifies to 10. The x-coordinate of our vertex is 10. Let's find the y-coordinate. To find the y-coordinate, what we do is we plug in that value of 10 in for our x and solve for y. Now, we haven't done a lot of work with function notation, but that's essentially what this n of x is. That's basically our y value. This does not mean n times x. So I can represent plugging in x to find y by writing n of 10. N is a function of 10 with an input of 10. So this is negative 0.45 times 10 squared plus 9 times 10 plus 11. 10 squared is 100, so this is going to be negative 45 plus 90 plus 11. Negative 45 plus 90, let me continue this right up here, is positive 45 plus 11, which means my answer is 56. Okay, we have our vertex, but what does this vertex mean? I know that in the problem, x is the number of days since the concert was first announced. We're asked the question, when will the daily ticket sales peak? So when will it peak? It will peak 10 days after it's announced. And then it asks how many tickets will be sold that day. N of x is the number of tickets sold that day. So our answer is that 56 tickets, there's a tongue twister, will be sold that day.